Is the Smart Buildings Academy podcast with Phil Zito, episode 377. Hey folks, Phil Zito here, and welcome to episode 377 of the Smart Buildings Academy podcast. In this episode, we are going to be talking about BAS input and output selection. So we're basically doing hardware engineering. Now, for those of you who are listening to the podcast recording after it is done, you need to go to podcast.smartbuildingsacademy.com/377. Because this is going to have a lot of screen shares in the episode. We're going to be going through some stuff, and you'll be like, what the heck is he talking about if you're not seeing the screen share? So if you're listening to this after the live recording, definitely go and check out podcast.smartbuildingsacademy.com/377, where you will see what I'm sharing on my screen. All right, folks. So in this episode, like I said, we're going to be doing hardware engineering. We're going to discuss how to properly select inputs and outputs for our BAS projects. We're going to be focusing in on looking at a specification and a MEP set. We're going to be selecting inputs and outputs. We'll talk about like how do we pick between the different ones, and we will then just size and select things. Pretty straightforward. To do this, we are going to be utilizing the documents from our hardware design and sizing course. So what we're going to do is we're going to go and grab those documents. So I'm going to download that real quickly. And we're going to be going through inputs, outputs, and stuff like that. So let's bring up those documents and let's start talking through things. Before we get into all of this, the first thing we need to understand is that we are going to be dealing with physical inputs and outputs, and we're going to be dealing with I/O hardware. So physical inputs and outputs are on our controllers, and then we have I/O hardware, things like actuators, sensors, etc., that we're going to have to select. Let's talk through our inputs and outputs first, just get everyone kind of on the same page. Do realize, because I get feedback all the freaking time on the podcast, that I may call it something different than what you're used to. I may call it a dry contact, and you may call it a resistive contact or something. I'll do my best to make it clear, but do realize that certain people in certain parts of the world call things different things. So on the input side, we have dry contacts. Those are going to be things like our statuses, anything that is dry, so it's not wet, so it doesn't have electricity flowing across it. We're going to have resistive inputs. The big difference between resistive and dry is that resistive has that 5-volt DC signal typically going across it, and then you're measuring the resistance. Sometimes that's not how everybody's resistive inputs work, but those are going to be for typically our thermostats, 1K nickel, 10K type 2, stuff like that. We have our voltage inputs. These are volts DC, typically 0 to 10, 2 to 10, 0 to 5, 1 to 5, etc. volts DC. That's typically for things, powered sensors, either externally or internally, things like humidity sensors, etc. And then we have our 4 to 20 milliamp. The big difference between 0 to 10 and 4 to 20 milliamp, besides for the true zero, which, if you set 0 to 10 volts up right, you can create a true zero. But the big difference there is with 4 to 20 milliamps, typically you have to measure in series. You can't measure in parallel when you're doing your point-to-point checkout. Additionally, it deals better with long runs due to it being current and not voltage drop. And it also enables us to go and deal with interference as well. So that's inputs. Outputs, we've got our standard digital outputs, DOs, sometimes called voltage outputs. This is typically 24 volts AC for things like on-off actuators, on-off relays, etc. It can be both internally and externally sourced. And we have our floating outputs. These are two outputs with a shared common, clockwise and counterclockwise rotation. And then we have our 0 to 10 volt DC outputs. This is typically for proportional things like actuators, speed drives, etc. And we have our 4 to 20 milliamp output. That's our current output, and that is typically used for the same stuff. All right. That being said, let's dive in. So when you go to do your engineering, and ultimately when you go to do your takeoff, you're going to get something like this. It's a specification. You can see this is a more modern one because it's Div 23. This was given to us by one of our customers, and they gave us permission to use this in their course. Or in our course. So we're going to go through it. The specification, for those of you who haven't listened to our spec podcasts in the past, breaks out typically into 3 parts. Part 1 is general. Part 2 is going to be material, where we're going to spend a lot of time today. And part 3 is execution. So and the specifications, by the way, you have your divisions are basically like who owns the work, and you have your general conditions, which override all divisions, and you basically inherit them. This is things like job site safety, job site payments, stuff like that. And then we have our you gotta forgive me, I gotta take some water. We have our divisions related to building automation, Div 23. Maybe you've heard of Div 25. That's like MSI work. Part 1, general. This is going to give us a narrative. I don't know why my throat is so dry today. And this narrative is going to tell us, like, what does the system do, related specifications, etc. We're going to skip over a lot of this. Where we're going to focus in here a little bit is going to be things like general product description, like this is, hey, what components, what parts, stuff like that. What is furnished by us? This is important. So furnished, meaning we have to provide it as the contractor of this division, but we don't install it. Control valves, sensor wells, flow meters, etc. Installed but not furnished. So these are things we have to install, but we do not furnish. So for example, on the rooftop, thermostats and duct pressure sensors, we have to install them, but they're provided by someone else. And integrated to, but not furnished or installed. These are things we have to integrate to. So we're going to want to figure these out. And sometimes you'll have stuff that you just need to be aware of in here. Let's get down here to submittals. This is going to be our first thing we really want to dig into when we're doing product selection, because our product selection ultimately goes into our submittals, which get sent out, which then get approved. I'm going to check something real quick, make sure everyone's hearing me good. And then I'll be right back to the screen. Just let me go to this real quick. Sounds like everyone's hearing me. Yep. Okay. Let me unmute this site. All right, cool. All right. Everyone's hearing me. We're good to go. So submittals, this is super important. Like if you do one thing, please make sure you read the submittal requirements, please. It's the stupidest thing in the world to get your submittals rejected because you didn't include the proper amount of copies or anything like this. I'm increasingly seeing this wording right here. Excuse me. Gosh, submittals need to be approved or submitted within contract award. I'm starting to see this more and more. I'm additionally starting to see that people need to provide alternates if suppliers are not able to provide product. So it'll tell you what you need to include in the submittals. And then once you get through all of this fun stuff, you get into products. I'm going to fast forward through a lot of the BAS products, and we're going to go right down here to the actual devices. I'm going to skip through valves, and we're going to focus in on IO just for today. But let's keep going here. I'm sorry if any of you get motion sickness because I'm flying through this stuff. All right, let's look at this. So section K of 2 for our material. So we see temperature sensors. What we'll typically say is it'll say, all right, temperature sensors should be of this element type, should have this type of signal. This is the monitoring range, et cetera, output signal, et cetera. Now, how do you select your devices? Well, for one, you need to understand your count. And this is where takeoffs come into play. In a takeoff, what we're going to do is we're going to go to our one lines. Hopefully they exist. And we're going to do a count. And we're going to try to figure out our count of our sensors. And this is going to build our bill of materials. Now, what we'll typically do once we understand our one lines and we've got our count of inputs and outputs for each system type, we will then go up to the schedule and we will get a count of systems. So for system type VAV, we have 25 VAVs. So we would build out our input output list for the VAV. And then we would go and we would just say, okay, we got 25. So whatever that count is times 25, that gives us our count. That's typically how we get our count. And like I said, I don't know why my throat is so dry, so bear with me here. Now, we've gone and figured out our count. Oops, let me bring that back up. Sorry about that. 1 second. We figured out our count. Now we need to go and figure out our devices. And this is kind of the trickier part, right? So the first thing we have to determine is what kind of temperature sensors. We're going to use temperature sensors as our example here today. So we have room temperature sensors. These are either going to be actual smart temperature sensors from the manufacturer. These may be wall plate. We have to determine that. We have things like our duct averaging temperature sensor right here. So we have our duct single point temperature sensor. And this is where kind of understanding systems is going to come into play, because you'll know that your duct single point is typically going to be for discharge and return, whereas your duct averaging is going to be for mixing. My gosh, why is my throat so dry? So we have our duct single point temperature, and then we have our duct averaging temperature. We have our outside air temperature. Once we understand our point types, then we actually have to go. And I hesitate to do this because it seems like every time I do this, someone says I'm being sponsored by someone. So I'm going to tell you I'm not being sponsored by this person. I am just going to their site. So we're just going to go here. It could be anybody's site. So please don't send me that we're being sponsored by them, because. All right, so I'm going to just type in temperature. And then with temperature, I'm going to start to dive into, okay, what do I need? Temperature sensors and transmitters. Okay, oops, the wrong thing here. My gosh, come on. Did I say this is a live show? Because it is a live show. All right, so here we will go to duct. All right, now that I have duct, what I'm going to have to do here is I'm going to have to figure out, is this a, excuse me, 4 to 20 milliamp. All right, here we go. 4 to 20 milliamp sensor. And I can see this is 1K RTD. I don't know if it's platinum per the spec, but I can start to try to find that out by going to its data sheet. And I can start to dig into these sensors, and I can start to figure out, like, do they meet what I need? So I'll go here, duct, stainless steel, 4 to 20 milliamp. It doesn't tell me what the element type is. So I'll have to figure that out. That may be something that I have to send in an RFI or a call to this person, whoever is the manufacturer of this, But I know this seems like super difficult, and once you've done this a handful of times, you'll start to build up your list of materials, and this should not take you very long at all. Because the nice thing about building automation is pretty much every sensor or device IO that you could think of has already been used in pretty much most projects. So it's not going to be terribly difficult. But once you find this, this is called your catalog sheet. So you're going to save this, and you're also going to save the installation manual to hand off to your ops person as well. So selecting this, not terribly difficult. Then you go and you've got your sensor selected. You will add this to your submittal bill of materials. So it would say, DAT, so discharge air temperature, quantity, whatever, 1, sensor type, and you would grab the model number, and there you go. You've selected your input for discharge air temp. Now we have to get an averaging sensor. So, let's do the same thing. Let's go to temperature sensors, averaging. And all right, we're going to look at, should we look at some BAPIs? Let's look at some BAPIs. So here we'll go to BAPI, and we'll start to figure out, what do we have here in BAPI? Do these work for us? Doesn't look like they will. So we'll have to go, and maybe they got a catalog page. They do. So let's start to look at our catalog page. BAPI, BA averaging sensors, 10K type 2. We need 1K. So we have 1,000 ohm RTD. I don't know if these are platinum. So right here, okay, 1K RTD. Once again, we'll have to figure out if they're platinum. But this is how we build out this part number, right? BA, 1K. How long do we need the probe to be? Maybe we need a flexible 24-foot probe. So we've got that. Do we need a junction box? If so, is it going to be outside? Maybe we need a NEMA 3R weatherproof. And you build out. And this is very common. Like if you do, for example, IDEX, then, you're going to have to go and select from their catalog sheet. And they have this kind of build the part number listing right here. Once you've built out this part number, then you're able to go, oh, see, here's a related one right here. 1,000 ohm, 4 to 20. That's what we need. So we could grab something like this if need be. But once you've built this out, once again, it just gets right added to your bill of materials. Pretty straightforward as far as how this goes. Okay, let's say, what are we doing here? Let me bring up the spreadsheet again. Outside air temp. Let's look at an outside air temperature. And then after this, maybe we'll look at some outputs. Maybe we'll look at some BLEMO actuators or something like that. So right here, we have an outside air temperature. Okay. We need an outside air temperature sensor. Let's go. Well, we did BAPI already, so let's do ACI this time. So for ACI, like I said, we're going to go related documents, catalog page. Let's zoom in this bad boy right here. Let's see what they give us. They give us 1,000 ohm RTD. It's not going to be 4 to 20 though, output. So here we are, right? 1,000 ohm, 4 to 20. Right here. So I'm going to grab this guy, copy. We're going to paste it in here, and let's take a look and see what we got. See what it pulls up for us. So this is just a sensor board. I see. So what this sensor board allows us to do is take a input, it looks like, and then gives us an output. So we're able to put an input in and drive an output out if I'm reading this correctly. So that would be one way it looks like that we can convert this to a 4 to 20 milliamp signal. I'm not sure if that's going to be acceptable per the spec. We'd have to RFI that out, but super expensive to do versus just a normal 1K platinum or 1K nickel. Let's do some outputs though. So far, any questions on this? Pretty straightforward, right? We just go here. If I show this and I bring up our mechanical plans, super simple workflow. Review our section 1 of our spec, right? Part 1, review our general, understand our submittal requirements. Part 2, move on to products. And then we just go through and start to figure out our input and output types. What do we use? Once we've done that, we then go to our supplier of choice. For some of you OEMs, you're going to have all this built into an estimating tool already. For some of you on the SI side, system integrator side, you'll also have this built into an estimating tool. Others of you will just have a spreadsheet. And the workflow remains the same. Go to wherever your material listing is, search for the material that meets your needs based on the spec, go and figure that sensor out. And you've already done a one-line review, so you know what sensors belong to what system. And then you understand the system count from the equipment schedule, and you add those sensors to your bill of materials. Pretty straightforward. I'm going to pause to see if there's any questions before we go into outputs. Let's see. Anything anyone has a question on? Let me check on LinkedIn. No. Let me check on YouTube. No questions there. All right. Like I said, if you're tuning in, we are going through a bill of materials and a specification, and we're building our inputs and outputs for our bill of materials. All righty, so we've got to go to actuators. And here, let's just do something super basic, a 2-position actuator. So we'll just grab a really standard TF series actuator from Belimo. Go in here. That's the one we use right there in our course. I thought, no. That's not what we were going to use. Let me back out real quick. I don't want to fail safe. I just want a non-spring return LMB. There we go. That's going to be a little bit cheaper now. So go here to LMB 24 on off. There we go. Just your standard. So if we need to select let me know if you'd like us to do a episode where we get maybe Belimo on or someone like Belimo. Don't care who it is. Some actuator company, and we get them on and we have them do actuator and valve sizing, because we're not going to do sizing in this episode. That would just take too long. But let me know if that's something you want in the future, and we definitely could do that. But here, pretty straightforward, right? Go to our catalog page, select the appropriate actuator based on our inch pounds or foot pounds, depending on how you do it. And our signal type, if we need feedback or not, if we need an aux switch or not. And then select our model. And once again, just go and add it to our bill of materials. So pretty straightforward. Now, what if you do get a spec like I showed you earlier? Let me bring this up. Here we go. What if you get a spec like I showed you right now, where you get, it requires a platinum RTD and it requires a 4 to 20 milliamp output signal. But this is for a school. And so you're saying to yourself, maybe this is too high. Maybe this is too expensive. What do you do? This is where you would submit a add alternate or just an alternate as part of a RFI. You would say, is it acceptable for us to use platinum RTD resistive? So it's a resistive signal. Is that acceptable? If so, you will find that that will reduce your cost by anywhere from 30 to 50% for a sensor, because you don't have that signal conversion card inside the sensor. So you don't have that added expense. This is kind of why people use floating actuators in lieu of proportional actuators. Because if we go and we look at a proportional actuator, those can be pretty pricey. If you look at an equivalent floating actuator with the same foot-pounds capacity or inch-pounds capacity, that can be significantly cheaper because it does not have that conversion card inside it. So it'll save you some money. All righty, let's go and see what, oh, hit the wrong button. Give me 1 second. Let's go and see what questions we can answer for you all in the chat. What questions do you have about inputs and outputs? At the end of the day, this is pretty straightforward. You get your scope letter during your release to operations. With that scope letter, it's going to tell you what systems you should be implementing controls on. Then you're going to do a takeoff on your mechanical drawings. If there are no one lines on the mechanical, you can create your own, either by getting the equipment model number and getting it that way, or just general knowledge or what is in the spec. Then you're going to get a count of the equipment, and then you are going to go into the spec, figure out your requirements for your IO, and you're going to select the appropriate IO based on what you need. That is the hardware engineering process in a nutshell. Now, sure, there are some technicalities to things. You know, how do you size pressure sensors? How do you size valves? How do you size actuators? How do you determine flow meters and location placements? Those are all good questions, and those are all podcasts that we can cover in the future if you all are so interested. But right now, I just want to see what questions you all have, if any, related to hardware selection. Let me know, and I will answer those in the chat. All right, let's see. Let me check the couple places. Make sure. See on YouTube. See what we got. No questions there. All right, let's check LinkedIn. No questions there. All right. So coming up this Friday, we're going to have BACnet MSTP troubleshooting. I'm going to go through kind of the most common BACnet MSTP issues. We're going to talk about that. And yeah, then we've got a bunch of guests that we're going to be having over the next several weeks. So stay tuned for that. It's going to be a lot of fun. If you have any questions, this is the time. Otherwise, everything I mentioned will be available at podcast.smartbuildingsacademy.com/377, including a link to our hardware sizing and engineering course. You're welcome, Tarek. I apologize if I butchered your name. I can barely say my name sometimes, so don't take any offense. But thank you. I'm glad that we have helped you. If you have found what we teach valuable, I encourage you to leave us a 5-star review on iTunes, subscribe on YouTube, and hit the notification bell, and share us on your LinkedIn feed, wherever you're taking us in. So thank you, everybody. It's great to see the regular crew in here. Bruce and Andrew, good to see you. Thanks for being here. I have no freaking clue what's going on today. I'm like dying here, and I'm completely out of water almost. But fortunately, we're at the end of the episode, so we should be solid. That being said, thank you everybody for being here. Oh, well, Tarek, welcome to the world of facility management. First off, because Tarek says he is a new facility manager. Couldn't have found this channel at a better time. Thank you. First off. Second off, we're gonna have a lot of facilities folks on in some future episodes, and we're going to be doing some more energy and operational stuff coming up. So keep an eye out on that. Yeah, Andrew, it is tough to be out of water in Arizona. We have a cold front coming in. It's going to drop to, because we're getting snow tomorrow. It's going to be, let me take a look. Weather. It'll be 39 is the high tomorrow and 23 is the low. So as you can imagine, as you all should know about psychrometrics, as you go down past dew point and you subcool and then you warm back up, what happens? You're at a lower relative humidity rate, right? So that's happening in my office right now. It is starting to get cold. The heat is on in the building, and that is causing us to heat back up at a lower relative humidity. So while the relative humidity currently outside is not on this page today. Here we go. What is our relative humidity right now? It is 47% outside. If you can visualize a psychrometric chart, it's probably in the teens inside right now after you reheat up to 70 degrees. So definitely need a humidifier. I've got to go buy one. I just am so freaking busy. I never get around to buying one. I've got to get one. Yeah, I just have to make it happen sometime soon. So yeah, get ready for that dry air, everybody. It's a wonderful time. I mean, it makes heat transfer. Well, no, it actually makes. So that's a goofy thing, right? So the nice thing about moisture in the air is moisture can hold heat. So you can retain heat better. That's why the desert in Arizona goes and gets so cold at night, because there's very little moisture in the air. So there's very little retention of heat. Additionally, the surface doesn't retain heat as well, very well. So you've got that issue. But then in a building as well, right? You don't retain heat. And as you get less and less humid, because moisture is a great source of retaining heat. It sucks in the summer when you're trying to get that heat gone, but it's great in the winter. Alrighty, everybody. That's about all I have. Thanks so much for being here. I'll see you all on Friday. We're going to talk about BACnet. And as always, if you have any ideas, do not hesitate to reach out to us. And if you have any end of year funds for training, I encourage you to check out our training programs. Bruce, you want one of these shirts, or do you want one of our new shirts? Have you seen our new shirts? Bruce says, I still want a shirt. We have It's Control's Fault shirt. I'll wear it on Friday's podcast. I'll do that. And it's pretty cool. Bruce, I'll reach out to you offline. We'll figure something out. All righty. New or old. Yeah, I'm going to send you my used shirts, Bruce. So don't worry. I'm not even going to wash them. I'm just going to send them to you. That's how I roll. Then it's a true Control shirt. All righty. Thanks so much, everybody. I'll talk to y'all next Friday. If you have anything in the meantime, hit us up, podcast@smartbuildingsacademy.com /377. Take care, and I'll talk to you all Friday.